6.3, your turn. Here's the equation of a circle. X squared plus y squared minus 2x plus 4y minus 4 equals 0. Find the center and radius of the circle. Explain or show your reasoning. Okay. So, we have to do, let's follow Lena's steps, right? Those are pretty good steps. So the first thing she did in step 1 was group x terms together, y terms together, and she brought the constant term to the other side. So I see x squared and negative 2x, so I'm going to group those together. I see y squared and positive 4y, so I'm going to group those together. And now I've also got this minus 4, so I'm going to bring that to the other side. This is all going to be equal to 4. So already I can see, actually I was going to say my radius is 2, but I still have some work to do. So then I'm going to take these binomials, and I'm going to find that c term, that thing we didn't do now, right? Find that number that's going to make this a perfect square trinomial. So if I divide negative 2 by 2, I get negative 1. Negative 1 squared equals 1. So I get x squared minus 2x plus 1. All right, and I know since negative 1 is my magic number, it's going to be x minus 1 squared. All right, now for my y terms. If I divide 4 by 2, I get 2, and I know that 2 squared equals 4. So then I can just write this as y squared plus 4y plus 4. Now, I can also write this as a perfect square binomial, y plus 4. I'm sorry, y plus 2 squared. Right, 2 is the number, that magic number. So one thing I just did, maybe you should definitely, well, you definitely need to do this middle step here, is because there's also one step we need to do, which is balance our equation. So remember, I'm going to circle those numbers that I added to this left side that weren't there before. So that's plus 1 plus 4. So not only am I going to have my original 4, I'm also going to have a plus 1 and a plus 4 here. When I simplify all that, I get 9. All right, now I finally have my equation pretty close to being in the equation for a circle. You could leave it like this, that would definitely be valid, but I prefer to write this last term as the radius squared. So I'm going to write that as 3 squared instead. I'll just copy down the whole equation also. All right, so I've just completed the square for both these polynomials right here. So now I have it in the right equation to find the center and radius. So my center will be at positive 1, negative 2. My radius will be a length of 3. So if my center is at 1, negative 2, that's already in the fourth quadrant. It won't extend very far, but it actually will pass through all 4 quadrants. So I'm going to have to make a small graph, but include all 4 quadrants. You can also do this on Desmos. It's actually nice. You can't do some of the stuff on, I mean, you can graph a circle on your graphing calculator. It's above and beyond, so maybe that'll be some sort of extra credit, but really it's pretty simple to do by hand, I think. All right, so I know my center is 1 comma negative 2, so over 1 down negative 2. My radius is 3, so I'm going to set my compass to 3 units away from the center. 1, 2, 3. And so we see right there, that's 3 units away from the center. So that's what I'm going to use to go all the way around. Oh, I moved my paper too much. All right, so there's the graph of my circle. Here's my center, and it's a little bit off, I can see, so I guess I moved my compass a little bit. This really should be 3 units away, 3 units away. All right, If you notice, these are perpendicular bisectors, the horizontal and vertical lines. Since we're only dealing with integers, I know it's always going to go through those whole number spaces. So it's a little bit off, but I mean, it's pretty, I think it's close enough. All right. Are you ready for more? Okay. Triangulation is a process of using three distances from known landmarks to locate an exact point position. Find a point that is located 5 units from the point 3, 4, 13 units from the point 11, -4, and 17 units from the point 21, 16. Use the coordinate grid if it's helpful. All right, triangulation. Yeah, that sounds like something from like a cheap action movie. Like we're triangulating his coordinates. I don't think they're doing this by hand, but we will. Okay, so I'm going to plot the 3 points they give me first. So 3, 14, 3, 4, and of course it's like that. Come on. They should really have done different coordinates. Like, how do I know this is going to be accurate now? 11, -4. I mean, I guess I could do 2 perpendicular bisectors to find the exact point, but that just seems like a little bit too much work. And 21, 16. This has got to be a fourth of the way. So let me see if this is like halfway. That looks good. This is like halfway. This one's a little too far over. I'm just like, no, it'll be a quarter of the way. So like, I'm guessing that's about halfway. So I'm going half of halfway to get a quarter. All right. So using 3 distances from known landmarks to locate an exact position. Find a point that is located 5 units. Okay. So if I'm looking for something 5 units away from 3, 4, that's like creating a radius of 5 units. So I'm going to set my radius to 5. I know I'm at 21, so 5 less than 21 is 16. So that's at least that's pretty nice to find that. Not too difficult. Great. 13 points from 11, -4. So if I'm at 11, it's not so nice. If I go down 13, that goes to -2. So I'll go right in the middle of that, or what looks like the middle. Okay, something seems off. I hope I'm not. Oh, yeah, I know why something seems off. That's not 3, 4. I was like, how could this possibly be the same distance if these don't even intersect? 3, 4 is right here. So that's the one I want to do 5 units from. Great. Okay, of course it's not a nice number. So down 5 units from 3 would be -2. So I'm going to -2 on the x-axis. Right there. Okay, that looks about halfway. And really all I need here are these 2 points. All right, because those are the intersections of our 2 circles. I'll draw the whole circle, but we can make little dots here, or maybe we're doing triangulation, so let's make little triangles. These are possible points that if I'm asking to triangulate the location, that would be one of these 2 options, because these 2 circles intersect there. So I'll give the whole circle just so you see all the possibilities that are 5 units from the point 3, 4. All right. Not the prettiest circle I've ever made, but okay. Now we need to do 17 units from 21, 16. So 17 units is long, so it could really be either of those points. I'm not entirely sure. Yeah, I don't know. Probably this point. So if I'm starting at 2116, 21 minus 17 is 4. So we go to 4. Great. That's 4. And my guess was correct. This is so big, it's going to go off the grid. You could say that this point could have been a possibility, so I guess that would also earn it. But really, this is the point here. That's where all 3 circles intersect. That's the triangulating point. So I got to find the coordinate. It looks to be 6, 8. All right, so is there any sort of rhyme or reason? Could I have gotten this algebraically? I feel like maybe, I don't know. I don't know if there's a way. Yeah, I don't know. All right, if you could find a way, I'd have to think about it for a much longer period of time. To do this algebraically, I would be very, very impressed. But graphically is definitely way easier for me. So if you tried this, awesome, great job. It is kind of cool. All right, thanks.